A potential source of confusion in working out what statistics to use in analyzing data is whether your data allows for parametric or non-parametric statistics. It is safe to say that most people who use statistics are more familiar with parametric analysis than their non-parametric counterpart. In this video, I will be introducing to you the definitions of parametric and non-parametric tests, their advantages and disadvantages, and when to use these in testing hypotheses for your quantitative research. A parametric statistical test assumes about the population parameters and the distributions that the data came from. These types of tests include student's t-test and ANOVA test. On the other hand, non-parametric tests are also called distribution-free tests because they do not assume that your data follow a specific distribution. Parametric tests have strict rules and one should satisfy its assumptions before you can use it. These assumptions include but are not limited to the following. The level of measurement is at least interval and is normally distributed. However, if you satisfy all these assumptions, parametric tests have more statistical power than their non-parametric counterparts. Thus, you are more likely to detect a significant results when one truly exists. In the middle of the last century, it was widely believed that classical procedures such as the student t-test, the ANOVA f-test, the chi-square test, and related tests were robust to violations of normality, which means departure from normality does not affect the test that much. Early simulation studies tended to confirm that belief. Later, however, extensive studies with a variety of standard non-normal densities show that, in many cases, non-parametric alternatives such as the Wilcoxon Mann-Whitney test and the Wilcoxon sign rank test were substantially more powerful than the classical methods. Non-parametric tests are used if your area of study is better represented by the median. For instance, personal income can be better measured by the median where 50% are above and 50% are below the median. If you add a few billionaires to a sample, the mean is not the best way to represent your sample. When your distribution is skewed enough, the mean is strongly affected by changes far out in the distribution's tail, whereas the median continues to reflect the center of the distribution more closely. Another reason to use non-parametric tests is when you have a very small sample size. When you have a really small sample, you might not even be able to ascertain the distribution of your data because the distribution tests will lack sufficient power to provide meaningful results. Finally, you use non-parametric tests when you have ordinal data or outliers that you cannot remove. Typical parametric tests can only assess continuous data and the results can be significantly affected by outliers. Conversely, some non-parametric tests can handle ordinal data and not be seriously affected by outliers. Be sure to check the assumptions for the non-parametric test because each one has its own data requirements. It is commonly thought that the need to choose between a parametric and non-parametric test occurs when your data fail to meet an assumption of the parametric test. This can be the case when you have both a small sample size and non-normal data. The decision often depends on whether the mean or median more accurately represents the center of your data's distribution. If the mean accurately represents the center of your distribution and your sample size is large enough, consider a parametric test because they are more powerful. If the median better represents the center of your distribution, consider the non-parametric test, even when you have a large sample. Finally, if you have a very small sample size, you might be stuck using a non-parametric test. For more information about the recent studies about parametric and non-parametric tests, check the description below. Reference list is provided for your perusal. Thank you very much and have a good day.